Welcome to Chapter 3, Working with Linux. All right, so the first thing when we're working with Linux, and many people, especially those who are in this class, are not used to working with Linux. They're used to working with Windows or with Mac, right? And while Mac is, it's a Unix, as we talked about in previous presentations, it is not Linux itself. So there's definitely a lot to live and learn, all right? And as we all know from things, the more we experience something, the more we use it, the better we're going to be. And if you truly want to learn Linux, probably one of the best ways to do is just to go cold turkey. And by that I mean, just try to stop using your Windows and your Mac computer. Just use Linux for everything that you do. And you may go, no, I can't do that. There's software. No, well, look, go try it out. Go experiment with it. All right. Most Linux distributions, at least I've used, you can run off a flash drive without hurting your computer at all. So you can at least go try it and go see. Is it going to be a little slower off the flash drive? Yeah, it's going to be slower off the flash drive. But still, you can go try it and play around with it. For everyday tasks, Linux is stable and easy to use with the right distribution. So if all you're doing is emailing, web browsing, doing Office applications like Word, Excel, PowerPoint, there are alternatives to those on Linux that are free. You don't even have to pay for it. Or streaming videos. You're watching YouTube or Netflix or things like that. You can do all of that on Linux. All right. So most of what I'd say the average person is using on their computer for, you can do it on Linux without really any fuss at all. All right. Now, if you do get into the more, custom things, like you're like, I want to run AutoCAD on my Linux computer. All right, then you might have a bit of a problem. But I would say for most things, you can run Linux without any issues at all. All right. Now, once we get into the wonderful world of the CLI, the command line interface, now you're going to start having a lot of problems. All right. And definitely, again, to work in Linux, I would start with the GUI. All right. Get used to what things are called, where they are, how you use them, and just experience that first. And then once you start getting comfortable with that, or even just a little bit comfortable, then start experimenting with the terminal or the command line or Xterm, whatever it's called in your specific distro. All right. And start playing around with that. All right, so on the desktop installations of Linux, you're basically always going to boot right to a GUI. If you go to a server, there's a good chance it's going to boot right to a terminal. All right. Now, for the command line interface, if you do have a GUI up like this running, most likely you're going to be using a virtual terminal to access the terminal. Now, virtual doesn't mean that like, oh no, we're accessing it remotely or things like that. No, it's just mean that it's an application that's accessing the terminal, or pretending to be the terminal. It's not actually your main terminal running. So this is something that you can do right from your GUI. You could click on the icon right there. I believe that one, at least. Let me get the pin out. Oop. I believe that one is the terminal button here. Not positive, but that's my best guess. So you can do that. All right, so that's going to be the GUI terminal. Now, if you're doing the virtual terminal, sorry, I did misspeak a minute ago. So virtual terminal, I meant GUI terminal. So the GUI terminal, that's going to be applications that emulates the terminal window. If you're doing a virtual, you can run that at the same time as your GUI. You could either switch between them, being purely terminal or purely GUI, or using the GUI, and that would be yeah, that's going to be its own little application. It's kind of be a whole screen. You're not going to have the option to do Windows or anything. It's just going to be a terminal. That you will need to log into. So it's going to ask you for your username and password. And the other thing is, I've used the term terminal, I've used the term Xterm, I've used the command line interface. They're all basically the same thing. All right. They're all coming back to using the keyboard and mouse and typing all your commands out and those types of things. All right. So a little bit of give and take there, but for the most part, terminal, Xterm, some command line, they're all referencing the same thing. Now, when it comes to applications, all right, and the big one here is the kernel versus applications. All right. So the kernel, as we've talked about, this is like the core of the operating system. And I really like this metaphor that the book used. And it's the kernel is like the air traffic controller. All right. It handles everything in the background. It handles switching of application, takes care of loading and unloading tasks, takes care of managing devices and all those things. It is the one that is just like up in the tower, just directing everything left, right, forward, back, and out, whatever your case is. And it just keep passing those things on and off. Where if you look at your average applications, that is going to be the airplanes that would be under control of the ATC. So the applications are going to ask the ATC, hey, I need to run this code, or you tell the application to print something, and that tells the kernel, hey, we need to print something. And the kernel says, all right, let me take that, and I will then direct it off into the correct places. All right. Now there are a few different categories of applications. All right, there are server applications, desktop, and tools. We're going to come back to those in a minute. And then when it comes to access, all right, what applications do you have access to? Now, most of our current versions of Linux, the distributions, are going to have some sort of package manager, which again we'll talk about in a little bit later. And that makes really installing software just really easy. Now, your package manager may not have access to that software, that application that you want right off the bat. You may have to add some information to the package manager, so that way you can it knows where to find all the information it needs, or you may not be able to do it, and you may just have to manually install it. All right, and I believe we're going to talk about that in a little bit. So, but let's move on to server applications. So, server applications. There are a lot of them. All right, I've got just a few of them listed up here. I probably could have just put the picture up and not even had the text here, but I got both. But if we talk about web servers, all right, and the main tool here is going to be the wonderful world of Apache. That's probably the best, most well-known web server out there. Is it the only one? No, there are a lot of different options out there. All right, and what do web servers do? Well, they host content for web pages. All right, and we access them using HTTP, or more traditionally nowadays HTTPS, which is the secure version of HTTP, which is Hypertext Transfer Protocol. All right, so that's actually how we are getting the information off of that. And there are actually two different types of websites nowadays. There are static and there are dynamic. So a static website never changes. If you have a local company that you're helping support, or a local group that you're, a little club organization, there's a good chance that they have a static site. And that's all they need. They just need to display some information out there. But if you get to the more complex things, like Amazon.com, where, you can just go to whatever item it is that's out there, they don't have a web page for every one of those items made. What they do is they have a database, which you can see is a few options down. And when you say, hey, I need information on this product, they quick whip up that page for that item from that database. So they have all this information stored, and they're saying, okay, here's the title, here's the picture, here's the this, and they just are able to then build that site for you in that moment's notice. A great example of something that you might use that is a dynamic site, especially again if you're doing these like club stuff, would be WordPress. Part of web servers, you also might have Nginx and Nginx. This, according to my notes, is based out of Russia, and it has a lot of uses. So this is definitely something that is being used a lot with web servers. And one of those is what's called a reverse proxy. So when you say go to this website to help protect your internal IP addresses and things, your computer actually goes to a DNS, which says, hey, what's the IP address for this, which then sends it off down the IP address route. And when you come back into that server, which might be hosting multiple websites, instead of it going right directly to your thing, it goes to the Nginx server first, which says, oh, that's over here at this IP address, which then forwards your request to that location. So it allows you to do reverse proxying and have multiple websites running off one server and things like that. So it is a really powerful portion of the web server. We also have private cloud servers. All right, there's also public. We're going to talk about different cloud servers in a little bit. But private cloud servers are cloud applications that you're going to be running from your location. So you're going to have your own server running cloud applications. What would be some cloud applications? Well, Google Drive, OneDrive. The list just goes on and on and on nowadays. There are a lot of different options out there. And there's a lot of benefits to having your own private cloud server. It's, you control the hardware and the software and the security and everything else. You don't have to follow the rules of whatever company that you're paying to host their stuff, you're using their stuff on. So you can have your own. Some great examples of alternatives for Google Drive and OneDrive would be OwnCloud and NextCloud. All right, these launched in 2010 and 2016. But they allow you to basically have your own Google Drive running at your house, which just makes, you back to you in control of your own information. So again, give and takes to all these things. So those are some private cloud servers. We have databases, as I just talked about a minute ago. Most databases nowadays are SQL based, which is structured query language. And in this, we have the database stores the information and also allows for easy retrieval and querying. So you can search and pull information out very easily. And this is definitely kind of taken over the world since it's kind of become the standard. I mean, just imagine it's just like a giant access database, but it's an open source alternative. And there is some open source software, and there's probably some proprietary softwares out there that are all based off the SQL database. But database servers are the backbone of most online services. So yes, as I already mentioned a minute ago, with web servers, the databases are going to be used for dynamic websites. So they're going to pull information out of this database. One popular fork of MySQL is MariaDB. All right, so they're both databases. You also have Firebird and PostgreSQL, Postgresql. So there are different options out there. Next, we've got email servers. All right. If any of you had any have thought about how do you get emails? All right. It's, getting Gmail, I get an email. That's how it works. Well, email servers actually have three main tasks. So they have the mail transfer agent, the MTA, and this transfers electronic messages from one system to another. So when you send your email from Gmail to Yahoo, the MTA is the one that's telling Yahoo, hey, I've got a message for you, and it sends it over to there. Then you have the MDA, not MD as in dog, so the mail delivery agent. That stores the email in the user's inbox. So that's basically, it's saying, okay, we know there's a message here. Well, we're just waiting for the user to come get it from us. All right. And then the last one would be the post office protocol, and which also goes along with the internet message access protocol. So POP and IMAP. All right. And this is how we actually get our email off of those servers onto our local computers. So this lets an email client running on a computer talk to the mail server. And this is pretty standard nowadays, is how it's set up. You used to have to know all these settings and things like that, and nowadays you just kind of type your username and password in and tell it to Yahoo or whatever, and then the clients, the apps on your phone just automatically are able to determine what settings to use, which is really nice. Another good application for servers is file sharing. And the really annoying thing here, there's not one great standard that everyone uses. If you're on a Windows-based network, you're going to be using the Samba plugin for Windows. So Samba allows a Linux machine to look and behave like Windows, so it can share files in a Windows domain system. All right. If you're on the Mac system, then on Linux, you're going to need to use NetaTalk. All right. And if you're doing native stuff from from Linux to Linux, you're going to use NFS, or the network file system. And this is the glory of this is the network storage is mounted just like a local hard drive. So as far as your computer is concerned, every application on it, that's just a hard drive that's on your computer. It's not like, oh, you got to go to this fancy networking spot. No, it's just a hard drive on your computer. So it definitely makes things really nice. All right. And I already did talk a little bit about the DNS, all right, which is our dynamic domain name system. And this converts the URLs to IP addresses. So again, when you're saying going to Amazon or whatever, the DNS is going to go, okay, Amazon is located at this IP version 4 address of 136.28.42.16. I don't know what it is, but that's just a nice little example. It's 4 numbers that are 0 to 255. Okay. We also do have IP version 6 nowadays, but IP version 4 is still the main one being used as far as I know. There are many different DNSs out there. Google has their own. There's 1.1.1.1. I don't know all of these. There's a whole lot of them out there, and technically some are going to be a few milliseconds faster than others. So you do have to pick which one you think you like, or you can let your internet service provider have a default one for you. So if you don't have one picked, it will just assign one that they use. So a little give and take going on there. All right. You also have DHCP, which is your dynamic host communication protocol. This stuff is getting a little bit on the networking side of things, but you could have a server running a DHCP server. And what the DHCP server does is it actually is what gives your computer the local network IP addresses. So every time you plug your computer in, it doesn't know how to talk to the network, but what it does know is how to broadcast saying, hey, I need an IP address. And the DHCP server will hear that and say, okay, what's your MAC address? And it goes, all right, here's an IP address, and it gives you one based on your MAC. Sometimes that DHCP will give your MAC address the same IP address every time you hook up. Sometimes it'll go, all right, here's the first one available, lowest one available. So yesterday you were 106, today you're 101, because there's only two devices on the network. All right. So there's definitely a little bit of give and take on there with the wonderful world DHCP and DNSs and everything else. When we get to the world of desktop applications, all right, I've got a few examples up here. So we've got some email applications, and again, this is pretty standard, used to download emails from your mail servers, all right. You've got your Creative Suite, and this is used for the creative types, all right. So this would be things like Photoshop or GIMP, Audacity, Blender, all right. Again, the list kind of goes on and on and on for creative types. You've got your productivity stuff, which would be your Office applications like OpenOffice, LibreOffice, whatever. You also have your web browsers for browsing the internet. Again, Chrome, Firefox, Edge, I guess Chrome. I don't know what that is on the screen here. but I assume that is another web browser there, just based on the logo. It's probably a modification to Google Chrome or something like that, but I could be hardly mistaken. All right. Anyway, so there's a lot of options out there for web browsers. And personally, for you, I always suggest having multiple web browsers installed on your computer, because if you're having issues with one, you can always just switch to a different web browser. And I have that problem in my own life. My Google Chrome will not go to one website for me. I can get there, I can get logged in, logged in kind of, but then the page never loads. I never get past that. It's just a white page. And it is definitely some sort of cookie something issue. And I have not found a way to delete whatever that cookie problem is for that one website, which is really quite annoying. So I actually always use, and I always forget, but I have to use Firefox to use that one website. It's obviously one I don't use very often. So it is kind of annoying having to do that, but that's just the way the cookie crumbles sometimes. And lastly, we've got tools. All right. And there are a lot of different tools out there. All right. So we'll talk about some. And when it comes to tools, one of the biggest ways that we're going to interact with Linux is the shell. All right. What shell are you using? All right. And there are two main different shells at this point. There's the Bourne shell, which is also the bash. All right. And then there's the C shell, the letter C shell. All right. And then the beautiful thing about shells is we can be done remotely or locally. So you could SSH into your computer and access things, or you can do it from locally or with a keyboard and mouse and a monitor. You don't need a mouse for shell. All right. And the nice thing about shells access is you can do a lot with them if you know what you're doing. That's the big key here. Over here on the right, I've got one showing all the local processes and things that are happening right now. And you can see the PID values are all different. So these are all different applications or processes that are running. And we got a lot of information going on here. We got CPU information, memory information, a lot of good stuff. So this is actually just monitoring what's going on. And this would be the top command. As you can see in the top left-hand corner here, it says top. So that's what's going on there. All right, so shell is a very powerful thing, and we will be using that in this class. I believe it's chapter 5 when we start getting into the wonderful world of the terminal and shell access. All right, so Bourne shell, this was named after the creator Bourne. And the interesting thing here, it's the Bourne again shell, so that's why it's bash. And this is probably what's used on most modern systems nowadays. All right, you also have a set of C shell, which is the syntax based off the C language. And there's 3 other options that I've got listed in the notes, which is TCSH, KSH, and ZSH. All right. And the shell is your choice as a user. You can say, I like this shell, I like that shell. Probably most of us are going to just like whatever the default shell in the first system we used was, unless you purposely go out and explore different shell options for whatever reason. But I'd say most of us are just going to stick with the Bourne shell, and it's the one that works, probably the most consistent, I should say. And the nice thing about using the one that's probably the most consistent is it doesn't matter what Linux system you go to, that one probably is going to be an option there. So you will be pretty good with that one in the long run. Now, as part of the shell tools, we have text editors. All right. Now you have text editors on your Windows computer, like Notepad. And if you on Windows, if you don't use it, use Notepad++. That is so much better than like traditional Notepad. A lot of different configuration options, especially for programming and things like that. Notepad++ is light years ahead of Notepad. But in the built into shells, and not built in the shelf, applications that are available in the shells, we've got VI or Vim. All right, that is probably one of the bigger used one out there. And then you also have Emacs. All right. Now, this is, again, the text editor that is built right into, not built in, is an application that's available in the terminal. All right. So it's just this black screen like this where you can modify files and tweak things and do things like that. Both of those, Vim and Emacs, are going to have very steep learning curves. But once you learn how to use them, they are very, very powerful tools. You can search, you can replace lots of things at once. It is amazing what you can do. Some other options you also have are Pico and Nano. These are they provide basic text editing. All right. So Nano to me is definitely a good place to start. It gives you some shortcuts at the bottom, what's going on. It's a very good starter one. But if once you get to you've kind of mastered it and you're like, I wish I could search or this or that or whatever, Vim, VI or Vim or Emacs, they're going to be a much more powerful. So you should really take some time and learn VI. It's probably one of the most used ones. And I think it's also basically installed in every system by default. So it's a great one to have where Nano may not be installed by default. So a little give and take there. Some other tools that you might use would be network configurations. All right, so what's my IP address, which I don't see listed at the top up here, which that's fine. But so commands for that one from the terminal would be ifconfig, all lowercase ifconfig, no spaces, or our IP space address. That's another one that you might use depending on the system you're using. So that would tell you information about your IP address and things like that. You also might be doing some scheduling with cron tab. That's the one that I've used the most. So it allows you to say it allows you to pick an hour, minute, I don't know about seconds, day of the week, day of the month, month of the year. So there's like 5 different columns that you can pick, and you can say, I want it to run on the 3rd of every month at 3 a.m. And you can fill out the columns for that, and you leave stars for the rest to make it basically mean at every one of those. So if you want something that always run at 3 a.m., you put a 0 for the minutes, 3 for the hours, and the 3rd of the month or whatever day of the week or whatever for that. So it allows a very nice configuration, a lot of capabilities there. Now I mentioned earlier that we were going to talk about package management, and here we are. All right. So in the past, if you wanted to download something, that meant finding the source code. You would download the source code. You would then have to set up the source code. Then you have to compile the source code, and then you would finally be probably just about ready to then use whatever application is what you wanted to install. Is it the worst thing in the world to do? No, it is definitely something that you should learn to do at some point in your life if you're going to be working with Linux, because there will be software that you're going to want to use that your package manager might not have. All right, so not the best thing, but it is one of those just things that if you can do it is a very nice skill to have. So it's definitely worth learning. However, most of what we're doing nowadays is packages. And about a package in the wonderful world of package management is just a compressed files that bundle up applications and its dependencies. So it's like, oh, you want to install this Wi-Fi, access Wi-Fi manager from, I don't know, whatever. Okay, so here's the package you need, and oh, by the way, you also need all these other packages. All right, and it includes it for you. When you tell to install it, it's like, we're going to install 13 new packages. And you're like, what? I told you to install 1. Yes, but you need all those other ones as dependencies for it to work. So the package manager has gotten really smart, all right, and it's wonderful. If your distro is based on Debian, that uses .deb extensions for its package manager with dpkg, which is the most powerful tool for package installation and removal. But there's also a better one for novices, that is apt-get, apt-get, or just apt. I believe they are getting away from the -get option. And many of these package managers will also have a GUI available for you, so you don't have to do it all from the terminal, but you can. If your Linux is based on Red Hat or derived off of Red Hat, those types of ones, then you're going to use the RPM package management. And surprise, surprise, the file extension is that RPM. All right? And there's also a GUI available for that. And then over here in the pictures that I have, all right, all of these are also different package managers that you could install. So you might use your normal package manager to then install maybe one of these package managers. Again, and there is definitely benefits and downsides to doing this. All right. Personally, I like to keep everything in the main package manager that I can, but sometimes it's just not available. Sometimes it's like, oh, you need to get this or you need to do that, and sometimes it's just easier just to suck it up and move away and go to the other options. So there's a lot of options out there. Now, when it comes time for development, all right, say you're a computer programmer or something like that, you're going to have 2 different types of compilers, or even just running your shell scripts and things. We have interpreted languages and compiled languages. So interpreted languages, you translate the written code into the computer code as the program runs. So you're like, hey, I want to run this Python or whatever script. And it's like, okay, line 1 says to do this, convert that to machine code, run it. Line 2 says this, convert that to machine code, run it. So it's doing this all at the exact same time. The benefit of doing it this way is you have much quicker runtime. No, not necessarily runtimes. Your actual program runtime may actually be longer. It's probably longer. But you don't have to wait for your program to compile before you can run it. And that is definitely a big benefit. You're like, okay, just let me write it, hit run, and it instantly starts doing it. Not, all right, let me take 10, 20, 30 seconds to read through your code, compile it, make sure there's no errors. Okay, now we're good. Now you can run it. All right. So interpreted is it's converting the code as it's running it or translating it. While compiled languages first translate everything all at once, and then it actually runs it. All right. The picture I've got on the screen is of some examples: Python, Java, C++, JavaScript. Yes, JavaScript is different than Java. C#, Ruby, Perl. The list just goes on and on and on. There are a lot of different options out there. When it comes to security, all right, and while this is, mainly talking about Linux in this class, this security is good for most of the operating systems that you're going to use, all right? The first one is cookies. Now, cookies, as we all should know, they are delicious. We should just eat them all, right? Now, cookies are used to track you on the web. All right, they're a little piece of information that are stored on your computer, and they're designed to make your life easier, which is a wonderful thing. All right, so they can be good. They can save your shopping cart on a website. So, say you go to Amazon.com and you put whatever in your shopping cart, you save it for later, and you come back the next day and it's still there. So you can now just say, "Yep, I actually want to buy those things." Hit the button and done. It's wonderful. All right. However, they can also be used for cross-site tracking. So when you put that stuff in your Amazon cart, you looked at something on Amazon, and now all of a sudden you're on a different website, and all of a sudden it's showing you an ad for that exact same thing you looked on Amazon. It's like, how did it know? What's it doing? Well, it used the cookie that's on your computer already from Amazon, with Amazon's permission, of course, to then say, hey, here's an ad for something that you might want to be interested in buying. It shows you that ad to try to encourage you to buy it. All right. So you need to tweak your privacy settings so that, and by doing that, you can make yourself more anonymous on the internet. Now, it can also cause some problems, which depend on those third-party cookies. So, personal opinion, whenever I get a pop-up that says you need to approve cookies for this site, I'm always saying, nope, you don't get any cookies, or only those that are absolutely required. As I give them as little information as possible. Also, when it comes to security, we need to talk about passwords. Um, and a good password management system is essential to security. All right. Hopefully, that good password management system is your brain. It's just you remembering every different password that is out there. And man, that can take a lot of work. All right. Especially since every password really should be its own password. You shouldn't reuse any passwords from site to site. So now all of a sudden you're like, oh, that's simple. It's this password. It's like, oh wait, now I need to enter 200 different passwords. All right. I'm not even sure how many passwords I have in my password manager. That would be kind of interesting to look at. All right. But anyway, so you need to make sure you got good passwords for security purposes. The system admin for the server that you're gonna accessing is gonna have is the person who's gonna set up and enforce password policies. So that might be you need a minimum of 8 letters, or 15, or capital, lowercase, symbol, number, whatever that combination of all that is. They're the ones that are going to be saying you must do this, and if you don't, then I'm not going to let you on the system, type of thing. The most privileged user on a Linux system is going to be root. All right. And for security purposes, even if you have like a killer password on that root system, you should really disable root for security reasons. All right. It just helps protect your system a little bit, especially remote access from root. You should really not let SSH happen from root. That is just bad news waiting to happen. When it comes back to your passwords, you need to make them complex enough that they're not easily guessed by hackers, yet easy enough to remember. A lot of password generation services now are using like 4 words combined together with symbols between them and a number or something like that. So it's like, okay, dog, cat, horse, pony, or something like that. That would be your password with a dash and a 1 at the end or something along those lines. But if you have a hard time, like me, remembering all your different passwords, there are password managers out there. And ideally, you're going to go with one that was actually going to encrypt your passwords for storage. So that way you don't just have like a text file on your desktop of your computer with all your passwords in it. That would just be bad news. So you really want to have a file that is encrypted. And every time you need a password, it actually should decrypt it, give you the passwords, and then, re-encrypt it when it's done. So a little give and take there. Also, for security purposes, many places are requiring two-factor authentication. This could be text to a phone number. It could be a prompt on your phone saying, are you approving this? It could be a phone call. It could be you calling someone and entering the PIN number that they have on the screen in front of you from your phone number that they know is you. There's a lot of different options there. Many of us are absolutely it's a bad term. People don't like two-factor because I find it very annoying. Yet they probably will say thank you very much a lot when someone tries to get in their bank account and they're like, oh, that two-factor just saved me. So again, a bit of a give and take going on there. When it comes to protecting yourself, you need to limit the information you give to sites. All right. And man, sites just want to collect all this information on you they can. Why do you think Facebook is free? All right. They are serving you ads. They're collecting all the data they can on you, anonymizing it, and then selling it off to the lowest bidder and the highest bidder and every bidder in between. All right, they're going, okay, you want this information? It's going to cost you X amount of dollars, and if you're willing to pay for it, you get all that information. So Facebook probably knows what people on there have, dogs and cats, and there's in the age group of 25 to 30, we have 30,000 users in this geographical area that has a dog. They know that information. I've heard stories that Facebook sent a congratulations on being pregnant to somebody before they even knew they were pregnant themselves. just based on how what they were searching for and things along those lines. Like your body does weird things, and how you're typing stuff or what you're searching for, things like that. And, so that's kind of crazy that they can do that. So, yeah, make sure you limit what information that you give out, especially on public social media sites. That is just a treasure trove of information for people trying to hack your passwords. You want to make sure you use a password manager with random password generation so you can get random ones. Again, use unique passwords everywhere you can. Make sure you keep your systems updated for security purposes, for bugs and holes and things like that, for people could hack through. And then you should use firewalls to help protect you. All right. And again, as far as I'm concerned, any good operating system will have a firewall built into it somehow, some way. And lastly, there is privacy tools. And arguably, that Linux is one of the most secure operating systems ever created. That doesn't mean there's no weaknesses. That just means that it is more secure than the other. It's kind of interesting that Windows has the most viruses and things written for it. And when you look at the user database, Windows also has the most users out there, individual users, not necessarily access, but individual users. So it makes sense that people are writing viruses and things trying to attack Windows systems. Where Linux is this much smaller group. So in theory, there are going to be less people trying to hack into you. Now, again, as a novice person, if you're disabling things because you're reading a script on a website that says like, hey, if you're having this problem, here's your solution, and you're just like blindly following things without them knowing, you may be disabling firewalls, opening up holes or backdoors into your system that you may not even know. So make sure that you keep your system nice and secure. All right. And some ways that you can do that is VPNs, or virtual private networks. So this encrypts communication between you and your VPN server. So I actually have a personal VPN server running at my house. So that way, if I need to, I can log into my home network and make it act like, as far as my home network is concerned, I am sitting on a computer at my house. This makes things a lot easier when you have some home-built technology, home-built home automation stuff, and you have a wife who doesn't know how any of it works. So I definitely will remote in to check on things and maybe tweak some stuff, or access files is another good option for that VPN. Another one is Tor. And this one you might have heard is the Tor is bad. It's the underground of the internet, and I'm not going to say that it isn't. But doesn't mean just because you use Tor doesn't mean you're doing bad things. It just means that you care about privacy. So Tor relays internet requests through a network of servers that helps prevent you from being tracked. And I believe most Tor connections have 3. There's the entrance spot, there's a middleman, and then the exit spot. And sometimes you'll have even more hops than that. So the exit spot is actually, if you're going to use Tor, would be the most dangerous one to host, because in theory, all the illegal things people are using Tor for, or if someone is using something illegal, I should say, they're going to exit out your IP address. So you're going to be getting phone calls from people saying, hey, you can't do that, or whatever the case is. So you really don't want to be an exit node, is what it comes down to. Cloud computing. All right. And in the long run, cloud computing has revolutionized how we use and access technology. All right, right? It used to be you wanted to print something, you'd go to the computer that had the printer hooked up to it, and you'd print to it. Now you can print from anywhere in your house, or with a VPN anywhere in the world that has internet that can connect back to your house. All right. So it has definitely revolutionized it. All right. And we have, yeah, we're often not located in the same location as our stuff we're accessing. A great example of this would be our learning management for school, or learning management system for school. Just because I'm not at home doesn't mean or at school doesn't mean I can't access it. No, you can access that from anywhere that there's internet, and it's wonderful in that aspect of things. All right, so cloud computing has definitely changed things, and there's a few different deployment models that we have access to. So we have the public cloud, all right, and this is deployed by some sort of provider. So again, like Google Drive, it is deployed by Google. So they would be our provider. They're the people deploying this. And this is offered, as it says, to the general public and organizations over the internet. So anyone who can access it. And there are going to be multiple people who are all going to share that same cloud resource. So, there's, I don't know how many millions of users Google has, but all of us using Google Drive are all accessing the same sets of servers. All right. Some nice benefit features here, cost effective. You only pay for kind of what you need. It's highly scalable. So as your company grows, you can just scale the resources. It's, again, universally accessible, so it doesn't matter where you are. And oftentimes the cloud providers will provide automatic data backups. So that way, if something happens, it's just like, oh, no, we can restore your data from this other magic point. Or, oh, no, that server crashed. That's okay. There's a backup run running right down the hallway for us. And we just instantly transfer you to that backup one. So There's a lot of benefits to that public cloud. Some downsides too, which is you never know who has your data. Hopefully they encrypt it all, but still, you never know who has it. There's the private cloud. All right, so this is set up for the sole use of a particular organization. All right, so down here at the bottom, you can see a public cloud. We've got a public cloud provider, and all these different companies are accessing it. And they're all accessing their own little portion of it. All right, where if you have a private cloud, everything on that main server, or at least of that server group, is coming back to you. All right, so this is going to give you that higher degree of privacy, right? Because in theory, you're the only person accessing the information on that server, right? It's not about being encrypted or whatnot. It's about you're the only one that has access to it. So that is nice. That takes us to the wonderful world of the community cloud. So this is set up for the sole use by a group of organizations and with a common goal or requirements. So we've got this community cloud. We've got 3 organizations in it. All right. And the benefit here is those organizations are all going to share the cost of that cloud service. So instead of you having to have your own private one, it's like, well, why don't we just pool our resources? We can get a better cloud service going for the same price, and we're all going to be a little bit better off. This also leads us to a hybrid cloud option. This is going to be composed of 2 or more individual clouds. And this could be a private cloud with a public cloud, and you're going to be accessing stuff on both. So we can leverage outside resources while retaining control of the sensitive resources. So it's like, well, we really want this, but we also want to be able to keep our data really secure. Well, that hybrid cloud is a good option. So we can have the private cloud at our own company that has all of your data records and things like that you really don't want out there. And then it's just like, okay, some of these files, these Word documents, storage from faculty, whatever, they can go on the public cloud option. So a little bit of back and forth. And in the cloud, well, there's a lot of advantages here. All right. So flexibility. So cloud computing must compensate for the fact that each organization has a unique, ever-evolving set of resources and requirements. So it's like that right now you need X, tomorrow you need X plus Y, and the next day you need Z. We're able to constantly be shifting and changing that as we need that, which is really good. All right. Well, this also allows for better accessibility. Again, having multiple clouds, you can also access it from multiple locations. If you think that Google has all of its servers located in one specific building in one specific spot, you would be horribly mistaken. Google has the exact same server running in probably 30 to 40, I don't know, 100 different locations, and it's redundant. So if one server just absolutely crashes and burns, they just redirect you to the next closest one. So really a big accessibility access there. By also having those multiple redundant servers, you also get better wait times per se, internet speeds, because instead of you having to go from here to Germany to get something off the Google server, it goes from here to Baltimore or whatever. So it's a much closer distance, so your speeds are going to be drastically increased. So that is also a big benefit. You also have those cost effectiveness. All right, we've already talked about reducing the costs by scaling what you need. So instead of you buying this giant server that's going to fit your need in 10 years, well, you just pay for what you need right now, and then you would say to someone, oh, I need to upgrade that to a 4-core, and they go, okay, and they click a button, 4 cores instead of 2 cores. All right. And one of the reasons that this works is because most of the servers that you're using out there are virtual servers. So it's not, again, you have this dedicated server that's just you, but that you have a subsection of that server that is purely dedicated to you, and no one else can really access that subsection. So some nice little benefits there. We also have management, all right, or manageability. So this leads itself to automation really well. And the benefit here with manageability is more and more people are learning these skills, which is meaning there's a larger workforce that's available for you that actually understands the cloud. It's not this mysterious thing to them. It's like, no, we understand it. We've been working on it. We've been playing with it, those types of things. So big benefit there. We already talked about security, how Linux is one of the more secure operating systems. And again, most of those virtual machines are running on Linux systems. We've talked about virtualization. We just did it, where one computer is pretending to be multiple computers. So we are dedicating resources from that main computer. So you have one server that has, 100 threads on it, 100 different processing cores per se. And you can say, okay, you get these 25, you get 25, you get 25, you get 25. Well, company D drops out, so 25 are now free, and you need more. So they're like, okay, we're just going to take those 25 spare from D, and we're going to put them to your company. So now your company has 50% of that CPU. So you are dedicating those resources to you, which is really nice. And especially since a lot of time, even though they're going to dedicate those, you will get this amount of resources. When your system isn't doing anything and sitting idle, they're able to then use those resources for something else. So as much as they're dedicated, they're also not 100% dedicated per se when you're not using them. So as long as you're using them, they're going to be dedicated for your systems. All right. And the newest one of them, the bigger hot thing I'm going to call it, is containers. All right. I personally use LXC, which is the Linux container type at home. Docker is a huge one right now. Everything's like Docker. It's just like, okay, you just um, download this image and run it, and you're good to go. And it definitely simplifies, a novice person getting something up and running if there's a Docker image, because they don't have to understand anything but how Docker works. As long as they can open an image up and understand like a little bit, you can basically get any software that already has a pre-written container running for you. So big benefit there. And that is the end of chapter 3.